For this question, we will be making mosaic plots. And now it's very important that you do your own here. I'll be doing one, but try to do your own right here. We see that we need to pick two categorical variables. So things that would work are things that are in red. Anything in red is a categorical variable. Anything in blue is not a categorical variable. We need to make sure it has 10 levels. Well, first, let's make sure we're using our random subset. Good job. Using something that has 10 levels means we can go to Analyze, Distribution, just to check. This does not have to be included in your output. But let's say I want to use major. Well, major doesn't have a count of 10 for each level. So with this in mind, it doesn't need to have 10 levels. It needs to have a count of at least 10. So things that would meet this requirement are not things like major. Things like sex would meet it because we do have at least 10 per level. Look at the count right here. If you have at least 10, that works. You can check anything you want. There's also another way to check this once we do our mosaic plot. But if I wanted to use views on economic issues, I only have 7 very liberal people in my subset. So I couldn't use this as one of the variables. So don't use the ones that have fewer than 10 count per level. What I need to do to make a mosaic plot will be fit y by x. And the first part of the question asks us to pick two variables that match that criteria, and then comment on what I believe the association would be and explain the nature of the association. So if we think about, let's use sex explaining people driving drunk, and let's go down here to driven drunk. So is there an association between sex and driving drunk? And in my mind, I think that, well, I think guys are more likely to drink towards drunkenness, and that would incur them to drive drunk more often. I'm not saying, oh, all guys drive drunk and no women drive drunk. I'm just saying that I think there's an association because I just think guys, I don't know, they're more likely to make this mistake, and guys are more likely to not, I don't know, to think maybe, it would not be manly. It's nothing not manly about saying to someone, I'm a little too drunk to drive, or frankly, once you've had past 1 or 2 beers, you shouldn't be operating a motor vehicle. 1 glass of wine at the dinner table is not a bad idea, but once you reach past 1, that's what I always say. 1 drink is enough. And once you reach past 1, give someone your keys. That is my rule of thumb for not driving drunk. 1 drink, don't drive anymore after that, because you don't want to chance it. So let's go back to the question right here. So after that long explanation about why I think it could occur, you just have to give yours. Let's see if I am right. And the answer is I am correct. I'm just going to clear row states. If you have something selected in here like this, you can go ahead to clear row states. And we see that association that guys are more likely to drive drunk. So this does meet my expectations. We need to go down here to the mosaic plot and remove everything but the count. And make sure you're doing your own here. Don't use the one I'm using. There's no rule against this one. This one's so open-ended, and it's kind of cool and kind of neat because you can check anything you want. You can look at all the sex differences between all these different things as long as it's red. Used tobacco might not work because that has a lot of different levels and might not have 10 per count. So with this in mind, I have my mosaic plot. I removed everything but the count, and I'm ready to take a screenshot. Now I like pretty much all of this output right here, and I'll explain why in a moment. Let's go ahead and take a screenshot of the output. There we go, there's my screenshot of the output using snipping tool, or you can use Command-Shift-4, and it looks nice and neat. With this in mind, what do we see here? The mosaic plot supports my theory. It doesn't mean my theory is true, but it gives support, it gives evidence for it. Why? Because the blocks are uneven. Now you might say, my blocks are a little bit uneven. Does that mean I have enough evidence? When we talk about evidence, we're talking about p-values. That's why I like this output down here. The p-value is the degree of evidence. The null for this test is that there is no association. The alternative would be that there is an association between sex and driving drunk. And we see here evidence for the alternative. Remember, the alternative is what you need evidence for. With this in mind, I have enough evidence because my p-value is way below 0.05. We have definitely strong evidence for the alternative right here. Let's go ahead and check our questions, make sure we got all the points. We did pick two categorical variables. I commented on whether I thought there'd be an association, and I also explained the nature of that association. I made a contingency table with only the counts in it. Also, these numbers right here, I'm going to underline them. These numbers, the 295, the 296, those would all need to be greater than 10, because that's the count of people who have not driven drunk, the count of people who have, the count of female, the count of male. These are the univariate statistics in here, as I totally messed them up. So with that in mind, I have everything correct. Do not do that squiggly stuff I just did right there. I was just kind of hovering over them so you could see. Discuss whether it supports the plausibility of a relationship. And yes, and that did match my expectations. Why? Because the blocks are uneven. And on top of that, the p-value also states it's below 0.05, so we definitely have evidence of an association. This p-value in here, we use the Pearson, which is our p-value. You'll learn that in a later chapter. The Pearson p-value supports the evidence of an association. And technically, the likelihood one does too. It's just a different test we don't use in this class. That is how to do question number 3. Go ahead and do your own. It's really not that hard to do. Any of these you can do in a matter of moments. Make sure you're using your random subset. Go here to fit y by x. You can ask, does sex explain if people have been on a mission trip? And right here we pull up the output. This one's an example of no association. We do not have evidence to reject the null. Whoa, how did those all reappear magically? There we go. So with this in mind, the p-value is way too high and the blocks are way too close. There's no evidence of an association between males and females and going on a mission trip. We see that I meet the level requirement, 10 per level right there and 10 per level right here. It's just the univariate, just the univariate. You could have smaller than 10 in the middle, and we see my random subset of 591. I have nothing excluded or hidden. We see the p-value down here for the Pearson, and it's way above 0.05, meaning no evidence for the alternative, and we can't reject the null, that there's no association. Good luck.